Let us look at percentage yield problems. So before we can do that, let us define what percentage yield is. So we know that percentage yield is given by actual yield divided by theoretical yield, and then we multiply by 100%. Okay, so this is the formula that we use to find the percentage yield. So this actual yield here is the amount of product that you obtain from the experiment. Okay, so once you conduct your experiment, the amount of product that you are going to get is what we are referring to as the actual yield. And in most cases, this actual yield is given in the question. And then this theoretical yield here is the yield that we are going to obtain after calculations. Okay, so we always have to find this theoretical yield here. So we use calculations, okay, based on the balanced chemical equation that we've been given. We are going to use molar ratios to find this theoretical yield here. And then once we have our actual yield and our theoretical yield, we're just going to divide those and then multiply by 100 to obtain our what? Percentage yield. Okay, so now let's look at some example problems. So the first one reads, phosphorus reacts with bromine to form phosphorus tribromide. If 35 grams of bromine are reacted and 27.9 grams of phosphorus tribromide are formed, what is the percentage yield? Okay, so notice that we've been given the actual yield here. So this 27.9 grams of phosphorus tribromide that is formed, this is the actual yield. So our work is to find the theoretical yield and then divide those two, and then we can find the percentage yield. Okay, so to do that, we'll have to write the balanced chemical equation. So we have phosphorus that is reacting with bromine. So we know that bromine has a 2 there down. Okay, so this is going to produce phosphorus tribromide like that. Okay, so the first thing that we have to do is balance this equation. So we notice that we have 3 bromine here, and then here we have 2. Okay, so it means here we can add the 3, and then there we can add the 2, so that we have 6 bromine here. Even there we have 2 multiplied by 3, which is 6 bromine. Okay, and then we notice that now we have 2 phosphorus here. So what we have to do here is just include a 2 there. Okay, so this equation now is balanced. And then after we balance this equation, we are going to find the moles of the bromine, okay, using the mass that we were given. And then once we find the moles of bromine, we are going to use the molar ratio of bromine to phosphorus tribromide to find how much moles of this phosphorus tribromide we have. Okay, so let's say moles of bromine. So moles of bromine, we are just going to divide the given mass divided by its molar mass. Okay, so what's the molar mass of bromine? What's the molar mass of bromine? So the molar mass of bromine is approximately 159.808. Okay, so we divide this. What are we going to get as our number of moles? Okay, so punch this onto our calculator. We're going to say 35 divided by 159.808. So I'm getting 0.2190 and then 901. Okay, so these here are moles of what? Bromine. Okay, so if these are moles of bromine, then we can get a molar ratio of the bromine to the phosphorus tribromide there. Okay, so we see that the molar ratio is just 3 to 1 there. Okay, the molar ratio is just 3 to 1. Let me create some space here. So the molar ratio is 3 to 1 there. I mean 3 to 2, not 3 to 1. So the molar ratio is 3 to 2. So if we have these moles of bromine, how many moles of phosphorus tribromide are we going to have? So we are going to say if we have 0.2190, okay, how many moles of this PBr3 are we going to have? So we just cross multiply. So we cross multiply we are going to have 3x is equals to, okay, 3x is equals to 2 multiplied by that number. So 2 multiplied by that number, I'm going to get 0.43802. So this is the number that I get, and then I'm going to divide both sides by 3, both sides by 3 to get the moles of this guy here. Okay, so x is going to be equals to, then we're going to divide that number by 3. So if I divide this number here by 3, my calculator is giving me 0.14601. Okay, so these are moles of phosphorus tribromide. Okay, so since we have the moles of phosphorus tribromide now, we can use these moles to find its mass. Okay, so how are we going to find its mass? We know that moles is equals to mass over molar mass. So now we have the moles, and we know that we can get the molar mass of this from the periodic table. So we are just going to say mass is equals to moles multiplied by the molar mass. So this is going to be equals to the moles 0.14601 multiplied by the molar mass of this. So add the molar mass of phosphorus plus 3 times the molar mass of bromine there. Okay, so when you do that, what are you going to get? Okay, so the molar mass there will be 270.686. Okay, so let us multiply this. So what do we get when we multiply this? I'm going to write the answer on top here. Okay, so when I multiply this, I'm going to get 39.5 grams of PbR3. Okay, so this value that we found here is our value for what? The theoretical yield. Okay, so this is the theoretical yield, and then in the question we've been given the actual yield. So we have the actual and the theoretical. It means we can now find our what? Percentage yield. Okay, so let's find our percentage yield. We're going to say percentage yield is equals to the actual yield, which is 27.9, divided by the theoretical yield, which is 39.5, and then we are going to multiply this by 100. So this here is going to be equals to, okay, so for significant figures I'm getting 70.63%. okay, so this here is our percentage yield. Okay, so that's it for this video. Please like, share, and subscribe to my channel for more videos. Question number 2 reads, silver nitrate reacts with magnesium chloride to produce silver chloride and magnesium nitrate. If 305 grams of silver nitrate are reacted in an excess magnesium chloride, producing 23.7 grams of magnesium nitrate, what is the percentage yield? Okay, so after all these words, let's write the balanced chemical equation for this reaction. Okay, so we have that silver nitrate, so I'm going to write silver nitrate reacts with magnesium chloride to produce silver chloride plus magnesium nitrate. So magnesium nitrate will be written like that. Okay, so this is the reaction that is occurring. So what are we going to do? We are first of all going to balance this reaction. Okay, so to balance this reaction, we are going to add a 2 there, and we are going to add another 2 there. Okay, so we see now that we have 2 silver Even this side we have 2 silver. We have this magnesium chloride should have a 2 there. Okay, so we have 2 chlorine here, and then even here we have 2, and then the magnesium, let's check, we have 1, even there we have 1. Okay, what about the nitrate? So this whole nitrate here is being multiplied by 2. Even this side, this whole nitrate is being multiplied by 2. So it means our reaction is balanced. So now what is happening in this reaction? Okay, we are saying that this guy is reacting with an excess of this guy to produce silver chloride and magnesium what? Nitrate. Okay, so this means that in this question we are not required to find the limiting reactant, because this magnesium chloride here with a 2 is in excess, so meaning this one here is our limiting reactant. Okay, so we've been given our actual yield that is produced. Okay, so 23.7 grams of magnesium nitrate are produced. So now our job here is to find the theoretical yield. So how are we going to find the theoretical yield? Okay, we are going to get the mass that we are given here of this silver nitrate and then convert it to moles. So we are going to say moles of silver nitrate is just equals to the given mass, which is 305, divided by its molar mass. So what is the molar mass of silver nitrate? Okay, so you just add the mass of silver plus the mass of nitrogen plus 3 the mass of oxygen. Okay, so that should give you a mass of about 169.872 grams per mole. Okay, so when we divide this, what amount of moles are we going to get? So you just punch this value into the calculator. So we have 305 divided by 169.872. Okay, so when I divide that, I get my moles as 1.7955 moles. So these here are my moles of silver nitrate. Okay, so if I have my moles of silver nitrate, it means I can use them to find the moles of what? Magnesium nitrate there. Okay, so I'm going to get the mole ratio of this silver nitrate to the magnesium nitrate. So we see that the mole ratio there is just what? 2 to 1. So if I have these moles now of silver nitrate, how many moles of magnesium nitrate I'm going to have? So cross multiply, we're going to have 2x is equals to 1.7955, and then we divide both sides by x, by 2 I mean. Okay, so divide both sides by 2, even this side you divide by 2. What are you going to get? Okay, so we are going to get x is equals to, so let's divide this number by 2. Okay, so if I divide this number by 2, I'm getting 0.8977 okay, moles. So these moles here are for what? Magnesium nitrate. So since now we have the moles of magnesium nitrate, okay, we can use the formula for mass is equals to moles times the molar mass to find its mass. Okay, so let's find its mass. So we're going to say mass is equals to the moles, which is 0.8977, multiplied by the molar mass of magnesium nitrate there. So what's the molar mass of magnesium nitrate? We're just going to add. Okay, so we add the molar mass of magnesium plus the molar mass of so we have a 2 there, the molar mass of this nitrogen multiplied by 2, and then the molar mass of this oxygen multiplied by 3 multiplied by 2. So what are we going to get when we multiply that mass? Okay, so I'm getting 14.8.313. Okay, so when we multiply this, what mass am I going to get? Okay, so I'm getting my mass as 266 grams of magnesium nitrate. Okay, so that is my mass there. So from there we can now find our what? Percentage yield. So this one here is our theoretical yield, this one here is our actual yield. So we are going to say percentage yield is equals to the actual, which is 23.7 grams, divided by the theoretical, which is 266 grams, and then we're going to multiply by 100. So once you multiply this, you should be able to get 8.91%. Okay, so this here is our what? Our percentage yield. So that's all for question number 2, and then let's look at question number 3. Okay, so question number 3 reads, zinc is reacted with hydrochloric acid to form zinc chloride and hydrogen gas. The reaction is carried out in a glass container that has a mass of 14.7 grams. After placing the zinc in the glass container, the mass is 29.5 grams. The hydrochloric acid is then poured into the container and zinc chloride is formed. The excess hydrochloric acid is removed, leaving the glass container and the zinc chloride, which together have a mass of 37.5 grams. What is the percentage yield? Okay, so for us to solve this question, we'll have to carefully understand this question. Okay, so remember we have this jar, okay, of this glass container. So this glass container here, okay, this glass container here, okay, on its own it has a mass of 14.7 grams. And then after they add zinc, okay, so they put zinc here, let's say this is our zinc. After they add this zinc, okay, the mass now becomes 29.5 grams. Okay, so meaning the weight of this zinc that they are adding plus the initial 14.7 is now taking us to this mass here. Okay, and then at the end we are told that we have the zinc container here. Okay, we know that this zinc container weighs glass container. Okay, we know that this glass container weighs 14.7 grams. And then they are saying at the end, as the reaction is done, only zinc chloride is left in this container. Okay, and this zinc chloride plus the container have a mass of what? 37.5 grams. So it means the mass of this zinc chloride plus the 14.7, they are giving us what? 37.5. Okay, so for us to find the actual yield and the percentage yield in this case, okay, we have to use these masses here. So first of all, let us find the actual mass of the zinc chloride that was produced. Okay, so actual mass of the zinc chloride, so I'm going to say actual mass of zinc chloride that was produced is equals to the mass of the zinc chloride plus the container, which is 37.5, minus the mass of the container, which is what? 14.7 grams. So when you subtract this, we are going to get the actual amount of zinc chloride that was produced. So this gives us 22.8 grams of what? Zinc chloride. So this is the actual amount of zinc chloride that was what? Produced. And then how do we find the theoretical mass that was produced? Okay, we use this guy that we can see here. First of all, we are going to find out how much zinc was in this experiment. Okay, so to find out the amount of zinc, what are we going to do? Okay, we are going to subtract that mass of the zinc and the container minus the mass of the what? Container. So we are going to say amount, okay, of the zinc initially in the reaction is just equals to 29.5 minus 14.7. So when we subtract this, what do we get? We get 14.8 grams of zinc. So this here is the initial amount of zinc that was in the what reaction. So we are going to use this amount of zinc to find the actual to find the theoretical yield, I mean. Okay, so how do we find the theoretical yield? So we always have to write a balanced chemical equation. Okay, so let's write a balanced chemical equation here. So we have zinc metal reacting with hydrochloric acid to form zinc chloride plus hydrogen gas. Okay, so how do we balance this equation here? We just add a 2 on the hydrochloric acid, so we added 2 here. Okay, so we know that this is the initial amount of the zinc that we have in this reaction. So let's find the moles of zinc. So moles of zinc is going to be equals to 14.8 divided by its molar mass. Okay, its molar mass is 65.39. So when we divide this, okay, what are we getting? So we go to our calculator. So we say 14.8 divided by 65.63. We are going to get 0.2263 moles of zinc. Okay, and then since we have the moles of zinc, we can get the molar ratio of the zinc to the zinc chloride, okay, to find out the theoretical yield there. Okay, so we see that the molar ratio there is just what? From the zinc to the zinc chloride. It's just 1 to 1. Okay, so it means the moles of zinc are equal to the moles of zinc chloride. So we are going to say moles of zinc chloride are just the same as the moles of what? Zinc. So we are going to write 0.2263 here. Okay, so now that we have the moles of zinc, we can use the formula for finding the mass. So how are we going to find the mass, which will be our actual yield? We are going to say mass is equals to moles multiplied by the molar mass. So moles we have, that is 0.2263, and then we multiply this by the molar mass of zinc chloride. So how do we find the molar mass of zinc chloride? Add the molar mass of zinc plus 2 multiplied by the molar mass of what? Chlorine. So when I do that, I find 136.296 as my molar mass. So when I multiply this, I'll be able to get 0.8 grams of what? Zinc chloride. So this mass here that we found, guys, is our theoretical mass. Okay, is our theoretical mass. So for us now to find the percentage composition, we just simply put these values into the what? The equation. Okay, so we're going to say percentage yield is equals to 22.8, which was our actual zinc chloride that was produced, divided by 30.8, which is our what? Theoretical, and then we multiply by 100. So what are we going to get when we do that? Okay, punch that on your calculator. I'm getting 74.03%. So this here is our what? Theoretical yield. I mean our percentage yield. Okay, so that's it for this video. Please subscribe to my channel, share the video, and watch out for more contents.